There's two rules, we call them the certainty rule and the precision rule. The certainty rule is involved with multiplying and dividing, okay? So besides certainty rule, we use this, use when multiplying or dividing. And this rule says this, very important. You're going to use this throughout the rest of your scientific career at STM, okay? Not even kidding. You use it all the time in every course. Ready? Here it is. Are you ready? Like, pull up your pants. This is going to be serious, man, okay? Okay. Round the answer to the smallest amount of Sig Digs in the question. Sorry that I kind of went off there. So round the answer to the smallest amount of Sig Digs in the question. Okay, so this is your example here, and we'll do a couple more. It says 3,245 multiplied by 28. Okay, so what you do is you look at, this is the question, okay, so that's the question. You count the number of Sig Digs in each number of the question, okay? So with the number 3,245 times by 78, 1, 2, 3, 4. There's 4 Sig Digs in that. I'm just going to go Sig Digs. There's 4 Sig Digs in that number, yes? And in this number, there is 1, 2 Sig Digs. Okay, so our rule says my answer needs to be to 2 Sig Digs then. Because what is the smallest number out of these two? Obviously, the number 2 is smaller than the number 4. So that means my answer must be in 2 Sig Digs. Okay, so what is the value of the answer? Somebody have their calculator? Or can you do it longhand? Nobody? You're going to need your calculator for this class. So, sure, yeah. You can just say the digits. 253,110. Okay, so that's the answer that we get. Is that in 2 Sig Digs? It is certainly not. So what do I have to do?
But if you put the 2 at the end.
If I put what? So what's my option? How can I write that into 2 Sig Digs? Put a decimal where? How can I put that into 2 Sig Digs?
Use scientific notation.
Very good. I use scientific notation. Okay, so I'm getting a little bit ahead of myself in the notes here, but I would have to put this into scientific notation because I'm only allowed 2 digits as my answer. Only 2. But if I put the number 25 there, that's not the same thing. If I told you that I owed you that much money and I gave you 25 bucks, you would not be pleased, right? So you can't say that that's the same number. So what I'll have to do is I'll have to put it into scientific notation, which I'll show you in just like 2 minutes. I'll give you a couple notes on that. But it'd be 2.5 times 10 to the power of 1, 2, 3, 4, 5. So that would be my answer. Okay?
But wouldn't that not give you the exact number, or would it?
It is not as precise, is it?
No.
That's right. That is an observation. Yes, this number that I just put it to is not as precise. But whatever my information came from, I only need to be as precise as what my question gave me. See what that is saying? You only have to be as precise as your question gave you. So if somebody said, I'm going to give you 2 apples and tell me how much you eat, you're not going to respond with, well, I ate 1.97654 part of your 2 apples. You wouldn't say that. You would say, I ate your 2 apples. You know what I mean? So you only have to be as precise in your answer as your question is. Since your question was only precise to 2 digits, your answer is only as precise to 2 digits. Okay? So that is the certainty rule, and with a little bit of scientific notation. Okay. So now we do the precision rule. You guys are doing good. Stay focused. This is important. Just try and stay as focused as you can. You're doing a good job. Okay, so the precision rule. If certainty rule was for multiplying and adding, what do you think the certainty rule is for? Yes. Great. You guys are awake. Okay? So we use this. Use for adding and subtracting. Okay? Now the rule states, now we do not use this rule as frequently in science because often our calculations will involve multiplying or dividing. But in the case that we have this is going to throw you for a loop. But okay, so this rule says round the answer to the smallest, I'm going to just put the number sign, number of decimal places. Okay, so this is a different rule. I only look at the decimal places. So counting the Sig Digs for this is a little different, which kind of throws a wrench into the whole thing. It kind of sucks, but we can do it. Okay? So, with this, when you count the Sig Digs for adding and subtracting, you only look behind the decimal place. So 12.4, there's only 1 behind the decimal place. 13.2, there's only 2 behind the decimal place.
So these are the ones that we count or that we don't?
That you count. So you're only concerned, with adding and subtracting, you're only concerned about things behind the decimal place.
And there'll always be a decimal one?
If there's no decimal, then there's no decimal. And so I'll show you an example of that, yeah. And then here there are 3. So again, you choose the smallest one. So the smallest one out of that is obviously the number 1. So you only have to have your answer to 1 decimal place. So with adding and subtracting, it's all about the decimal place. With adding and subtracting, it's all about the... With adding and subtracting, it's all about the... Okay, very important. All right, so let's figure that out. What is that? Where's your calculators? You guys will need them. If you have them, pull them out of your binders right now. So this is equal to 33.456. my answer only needs to be as precise as my question. And since this is adding, I'm only concerned about the decimal place. So I only need 1 decimal place. So I'm going to say my answer is 33 point something. Now, the next part gives us a hint about what we should do. Your very last digit, you look at the number behind it, and if it is greater than 5, you round up. If it is less than 5, you leave it. Okay? Okay, so that means since the number behind my last digit is 5, I round this one up. Have you guys done that at all before? You know that rule, right? Okay, so that rule we always have to apply to our Sig Digs. That you look at the number behind the last digit. If it's 5 or greater, round up. If it's less than 5, leave it. Okay?
So you don't have to change it if it's less than 5, just leave it at 4?
That's right. So if this number was the number 3, it would be 33.4. Yes. Okay, the last thing we have to do. Scientific notation. You guys have already got a roll and start on this, so good for you. Move the decimal place so that only 1 non-zero digit appears to the left. So you always want it to be like a number dot number. Okay, so what you think when you see this number, if you need to put it into scientific notation, so we go 0.2647. You think, okay, your goal for scientific notation, I'm just going to put it at the top of the page something, okay? This is your goal, is to have the first digit, the decimal place, so this is only 1 digit, other digits, however many you're allowed, and then times 10 to the power of an exponent. So you only got 1 digit first, then the decimal place, and then as much as your rest left, okay? So, here.
10 to what? The exponent?
Yeah, an exponent. Sorry, I didn't write the full word. So, when you look at your number, you think, which number is the first one that is not a 0? Okay, so I start on this side. There's a 0. There's a 2. Okay, 2 is not a 0, right? Agreed?
Yeah.
Great. So we move the decimal place over 1 spot. So now it is here. Okay, we moved it 1 spot. 1 spot. Okay? Drop all non-significant zeros. So now I can rewrite it as 2.647. Multiply this number by 10 to the power of something. Now that something is how many places you moved the decimal place. How many spaces did we move it? 1. So we got to put a 1 there. Now, if this is a big number, like bigger than 0, this number has to be a positive value.
Isn't 10 to the power 1 0?
Nope. It means that the decimal place has moved 1.
Do you have to write the positive sign?
No. Oh, wait. Never mind. This should be -1. We moved it. We made it a smaller number. It was a smaller number. Sorry. Ah. Okay, right? Because we started as a smaller number. This is a smaller number than 1. Okay? So let me, with your summary here, n is positive if the decimal was moved to the left. or if number is greater than 1. That's how you can determine. N is negative if the decimal was moved to the right, or if number is less than 1.
Isn't the number now greater than 1?
Pardon me?
Isn't the number now greater than 1?
No, this number is still less than 1. This number and this number mean the same thing. They're represented in a different way. Like 0, or sorry, the original number,
Okay, yeah,
right?
I got you.
Yeah, this was like the transition step.
Yeah.
Yeah. But
So if the original number is less than?
Yeah, the original.
yes, thank you.
Okay.
The final number is less than 1 too. It's just represented in a new way. You see that? This, if I was to convert this back out of scientific notation, I would get that.
Because how would you know what to do?
How would I know how to do that?
Like, will we ever be given like an equation and it will say go back?
Yes. So how about, that's what's on your sheet next. So how about let's do some of those together. Okay, so on your handout there, number two is, it says, so let's try that, and you can ask more questions as we try it. So it says, convert the scientific notation back into whole numbers. So let's try that. So A says 3.22 times 10 to the power of 6. Okay. So is this number bigger than 1 or smaller than 1? Bigger because why?
The exponent is positive.
The exponent is positive. Okay? If that would have been to the power of negative 6, it would be a really, really, really small number. But because it's positive 6, it's big. So what we do is we start with our 3.22, okay? And what the 6 means is we move 6 spots over to make a bigger number. Because you said since it's positive, we're making it bigger. So which way do I move the decimal to make it bigger? To the right or the left?
Right.
To the right. So I go 1, 2, 3, 4, 5, 6. And I like to make the bubbles so that I know exactly how many spots, okay? So now you add in 1, 2, 3, 4 zeros, and the decimal place is at the end. Now, usually when we just write whole numbers, we don't put the decimal place at the end. You don't say, how old are you? I'm 17 decimal place. No, you don't say that, right? You say, I'm 17, right? However old you are. You 16? You guys 16? 17, 16? 15 or someone do 15 still? Okay. So then you can rewrite this number as 3, 2, 2, 1, 2, 3, 4. Okay? This and this mean the exact same thing. Do you see that? You see, they mean the same thing. It would be like